In this video, I'll show you how to click to move your player, and I'll show you how to do it with specific objects. So for example, in this case, we can only click the ground to move. If we click this cube, we cannot move anywhere. And I'll show you 3 ways how to move the player. The first way is using the transform position directly, but that way will ignore collisions and will cause the player to pass through this cube and any other collision. And I'll also show you how to do it with character controllers so we can avoid collisions as so. See, it will not crash into this box here. And with a rigid body, just in case you wanted to move your player with a rigid body. And you see that wherever we're moving, the character rotates to face that direction.
So before we get into the nitty-gritty of it, I want to thank Southern New Hampshire University for sponsoring this video. Do you feel like your experience is holding you back from pursuing the career that you want? Southern New Hampshire University has one of the largest accredited, non-profit, online degree offerings in the United States. All of the programs are extremely flexible, there's no set class times, allowing you to work on what you want when you want. It's also super affordable. Their online tuition rates haven't increased in 10 years, and they're some of the lowest in the US. One program in particular that I think that you may be interested in is the Game Development Online degree. The game industry is a $190 billion industry and is rapidly expanding. And with this degree, you can learn to create realistic, dynamic gameplay experiences with game AI, game physics, 2D and 3D graphics, and interface design. You can learn programming languages like C++, C#, Java. You'll use Unreal Engine to make games for different platforms. You can learn 3D modeling and texturing, and the courses are taught by industry experts who'll teach you how to research, develop, and contribute to the advances and trends within the game programming field. So if you want to kick off your new career or take your current one to the next level, click the link in my description to get more information and browse all of their programs. So let's get right into it. This will be using the new input system.
So to start off, make sure you have the new input system installed, so go to Window, Package Manager. Up here under Unity Registry, we can scroll down until we find Input System. And I'm just going to install down here version 1.0.2 and click yes when the pop-up appears so that the input system changes are applied to the project. Alrighty, so I already have this scene set up, which is just a ground, a cube, and a player here. So under my scripts folder, I'm going to right click and create a new C# script, and I'm going to call this click to move. Alrighty, so I'm going to remove this using systems collections generic namespace since we won't use that, and for now I'll just delete these functions. So we'll need to use the new input system, so we need to import using Unity engine.inputSystem, so we can use the classes and functions within the input system namespace. And so there's multiple ways to read input using the new input system, which I have a tutorial on. In this case, since we only need one input, which is our mouse click, I'm just gonna do it this way. So let's make a serialized field, and then you can do private input action, and you can call your action mouse click action. So you see, if we go to the inspector on our player, we can attach this script, click to move, and here will be our mouse click action. We can add a new action, so add a binding, double click that, and under the path, you can add whatever binding you want. In this case, I'll add a mouse left button binding. You can also add interactions and processors through here. And so now our action is bound to the left button of the mouse. And when we go back to our script, we'll make it so that whenever we click the mouse, we'll call a function to move our player to our position. So first, let's write the function so that we detect when we press our mouse. So first, in the onEnable function, we have to enable our action, mouse click action.enable. And then after we've enabled our action, we can subscribe to the events for it. So in this case, we can do mouse click action dot, and then we'll want to subscribe to the performed event. So whenever this mouse click has been performed, you can also do started. In this case, it would work as well. Then we subscribe to the move function, which we need to define, which we can do here, private void move. And this event returns a type of input action callback context. So we need to pass in input action.callback context, and we can call this context. And the reason I'm subscribing to it as so and not using an anonymous function, if you know what those are, is so that we can successfully unsubscribe for this when we're done using it to avoid any garbage being created and not deleted. Alright, so this is called when the script is enabled. When the script is disabled, we need to unsubscribe for this event. Mouse click action performed minus equals move. So now we're not listening to this event anymore. And now we can do mouse click action.disable. So we can disable this action. Alrighty, so now this will be called when we click our mouse button. And now here is where we'll determine where we need to move towards. So our mouse is in screen coordinates, which is just a coordinate on the screen. Usually it's 1920 by 1080, and your mouse corresponds to one of those coordinates. But since our game is in 3D coordinates in our world, we'll need to convert from screen to world coordinates. And there is a function called screen to world point. However, in 3D games with perspective, the perspective messes up that conversion if you don't pass in the correct distance that the point is from the camera. But luckily Unity has a function that we can use, which is screen point array. And what it does is that it takes our screen coordinates and it shoots a ray from the camera center or origin forwards until it hits that screen position in this outer frustum, which I hope I pronounced that right, which is basically the field of view here of the camera, which is what we see on the screen. So we'll use that function, and for that we need a reference to our camera. So up here we can just do private camera, main camera. And then in the awake function we can just do main camera equals camera.main just to get a reference to it so we don't have to call this each time. And then we can do main camera.screen point array, and we can pass in the current position of our mouse. So this just triggers when we click our mouse, but we actually need the position, the screen coordinates, which you can get with the new input system from mouse.current.position.readValue. So this is just a global variable we can call. We don't need a reference to this, which is nice. And this returns a ray, so we can just call this ray squared. Alrighty, and then we can actually cast this ray, so this ray has not been cast onto the scene. And to do that in 3D, we can do physics.raycast. We can pass in our ray, so you'll see we have a ray parameter here. This is a way to easily tell what our inputted parameters are associated with. So in this case, this is the ray parameter. And here we'll be using a specific override of this physics raycast where it outputs the raycast hit information. So in this case, it's called hit info, and you can do out var hit. So it will output a variable called hit. Instead of var, you can just do raycast hit if you want to be more specific with the type. And so this will contain the information if we hit something, if we didn't hit something. So we can actually use that in this if statement. So right after this, we can do and hit.collider. This will return null if we didn't hit anything, and it will not be null if we did hit something. Once we output this hit variable, if we hit something, and I'll show you how to add the ground layer later. So we can do and our layer equals the correct layer, then we can execute this if statement. But for now, I'll show you how it's done without that. So I like to use coroutines, which you need this system collections namespace to use. So once we click on the correct position, we will call this coroutine called player move towards. So we can do private IE numerator player move towards. And we can just pass in the vector3 target of where we want it to move. And coroutines are super useful. I use them almost all the time. It helps make the update method very less cluttered. And basically, a coroutine will let you pause execution of something until a certain condition is met. All right, so we can call this player move towards. Right here, we can just do start coroutine and do player move towards and pass in the target, which in this case will be hit.point, which is the variable here. This will return the point where the ray hit the collider. And so I just want to mention there is a problem here. You see that once we click a bunch of times, this function will be called every time we click, and it will keep starting coroutines every time we click, which ideally we don't want to have a million coroutines running at the same time if the player clicks really fast. You only want to move towards the latest click. So we can keep track of the current coroutine and stop it before starting a new one, which up here you can just do private coroutine. And here you can equal the start coroutine to coroutine. But before we do that, we can check if coroutine does not equal null. So if it has been assigned, then we should stop the coroutine. Stop coroutine and pass in coroutine. Alrighty, now towards the coroutine. So basically what we want to do here is move towards our direction, and there's multiple ways to do this. I'll show you how to do it with the vector3 move towards first. So first we want a while loop. So while we have not reached our destination, in this case we can do while the distance, vector3.distance between our player. So if this script is attached to our player, we can just assume that for this video. We can do transform position and we can do target. So if our distance to our target is greater than a certain threshold, I usually put it at 0.1 f, then we have to keep moving towards our destination. So our vector3 destination, we can do this by using a function called vector3.MoveTowards, and this will ignore collision. So this will move past everything, which you'll see soon. So the MoveTowards takes in our current position and our target. So our current is transform.position, our target is called target, and then we pass in the speed, which we need to define. So in this case, I'll do player speed, and you have to times that by time.delta time, which will smooth it out over the frames. So up here, we can just define our serialized field, private float, player speed, and maybe you can just set that to 10 as an example. Alrighty, and now if we scroll back down, you'll see that we have an error here, and it's because since this is being run on every frame, you need to return a value in a coroutine, which usually you do yield, return, and in this case, we don't really want to return anything. We just want to wait until the next frame in this while loop. So you can just do yield return null in a while loop in a coroutine, and it will wait until the next frame correctly. If you don't do this within the while loop will just run crazy and you'll probably crash the program. Alrighty, and then I actually forgot, of course, we didn't set the transform position to our destination. So make sure to do transform position equals destination. If for some reason you're having some difficulties, maybe it's not working, an easy way to debug this is using gizmos, which are drawn on your scene view. So you can just do void on draw gizmos, private void on draw gizmos here, and then you can do gizmos.draw sphere at the position where you want it to be drawn. So in this case, we can just keep a variable up here called private vector3 target position. And then in this if statement, we can do target position equals hit.point. And then down here, you can do gizmos draw sphere, target position. And then here you see that it takes in a center and a radius, which you can just put a radius of 1 as an example. And you can also set the color. So gizmos.color equal color.red. Just in case you're having some difficulties, it can make it easier to debug if you can see where it's being clicked on visually. Alrighty, so if we click on our scene now, you'll see that when we click here, our player moves towards our mouse position, but you'll see that it passes through this cube. And another issue that we have is that the player goes towards the center of the floor, and that is because the player position is in the middle of the capsule. And so this will be moved towards where we hit on the scene with our raycast. So it will move towards the floor. So we need to add in an offset to make sure our player doesn't go through the floor. So that's pretty easy. All we have to do is before we move the player, we have to take into account the offset. So we can do float player distance to floor equals, we can get the current distance to the floor, transform.position.y minus target.y. So first you get the initial difference. Then what you can do is in this vector3.target, you can add in that offset. So target.y plus equals, and you can just add in the current distance the player has to the floor. And so if we press play now, you'll see that this distance is now maintained and there is an offset applied. Awesome, so this is one way how to move our character. So this ignores collisions. If you do not want to ignore collisions, which in most cases, you'd probably want to not ignore the collisions. You don't want your player to pass through objects. You have to use either raycasts, CharacterController, or Rigidbody. So I'm going to show you how to do it with a CharacterController and a Rigidbody. CharacterController. So the CharacterController, you use it if you're not using physics, and the Rigidbody, you use it if you're using physics movement with your character. So I'm just going to comment out this transform position equals destination so our player doesn't move there. And what we need is a reference to a character controller that we will assign to this game object. So here we can do private character controller. In the awake function, you can just do character controller equals get component, character controller. If you want to make sure that this game object has a character controller, you can do require component type of character controller. And so now whenever this script is added to a game object, a character controller component will automatically be added if it is not already. Alrighty, so with our character controller, there is a function called CharacterController.move, which is what we want to use. So we can do CharacterController.move, and here we have to pass in the direction that we want to move in. Not the destination, but the direction. So to get the direction, vector3 direction, what you can do is use simple vector subtraction. So to move towards a point, you do target minus our current position. And this will result in a vector pointing towards the target. I always like to think of it as this points to the target, and that's where we want to go, but without the actual point there. So that's the direction we want to go in, and we want to add in our speed. So we can just make another variable here called vector3 movement. And what you can do is do direction.normalized, which normalizes the vector, so it's just the direction and it doesn't have any length, it's just a length of 1. And then you can times it by your player speed times your time.delta time. And then you can pass that into the CharacterController.move function. Alrighty, so if we go back to our scene and we have to add in a character controller here, you can mess around with these values. If you have jumping for some reason and it's not jumping, make sure to put the min move distance to 0 or else you might have some troubles with jumping, just as a side note. Alrighty, if we press play, you'll see that now it works perfectly, and now when we click here, we cannot go past this cube because the character controller does not ignore collisions. Awesome. Alrighty, so now I'll show you how to do this with a rigid body. So I'll just comment out this CharacterController.move function. And now let's make a private rigid body RB. Then in the awake function, we can do RB equals get component rigid body. And up here, you can just duplicate this, comment one of them out, and just replace this with rigid body if you wanted to do that. Alrighty, and now here what we can do is alter the rigid body velocity directly, so rb.velocity. And there is a function called rb.movePosition, but that does ignore collisions, unfortunately. You'd either have to change the velocity directly or use rb.addForce. But addForce sometimes results in weird movements if you're doing it continuously. I just find it easier to change the velocity of the rigid body directly. Alrighty, so let's just change the rigid body directly. And the rigid body velocity is the direction that we're moving in, so we can just use the direction that we've already calculated up here and do RB velocity equals direction, and you can just normalize it times player speed. Alrighty, so now back to the inspector here. You can disable this character controller component, add in a rigid body to our player. Now for the constraints, what I like to do is freeze the rotation on the X and the Z so it doesn't freak out with the rotation. Sometimes it freaks out with rigid bodies. Alright, and you'll see that our character moves towards the point, but a couple issues. It kind of zooms past the point because the speed is too large. So if you want, you can decrease the speed. I'll put it at 3, and I also like to put interpolate here to interpolate to make sure that we have smooth movement within the rigid body. So this will interpolate the movement so it can look smooth on the player's side. And you can see that now it moves towards our position. So if we increase the speed a bit, you'll see that it kind of zooms past because we are changing the velocity and it does take some time to decelerate. So what you can do to prevent this is either increase the threshold here. So if it's greater than maybe 1, so that there's some time for it to decelerate, as so. Or you can just do an if statement. If it's within this certain range of the target, then stop the velocity entirely. And another issue here is that the player goes towards the center of the map, and that is because we do not have a collider on our player, because the character controller has a collider built in, so you don't really need a collider. But for the rigid body, just make sure to add in a capsule collider, and you can see it here on this screen. So now it will stop the player from kind of falling through the floor. But you'll see that there are some problems with the rotations, as I mentioned. So if you want, you can just freeze the Y rotation as well, and we'll change this rotation through code manually. Alrighty, so the last two things are making our player look towards where it's moving, and then making it ignore certain mouse clicks depending on what collider is being hit. So for the rotation, it's pretty simple. You can just do transform.rotation equals, and there is a quaternion.look rotation. So you can make it look at a certain direction, which we already have the direction here. So direction.normalized. However, this will be rather sudden whenever we move towards a new location. So what you can do is do quaternion.slurp to spherically interpolate between two values. In this case, we interpolate from transform.rotation to this new one with a speed of rotation speed, which we will put times time.delta time. Alrighty, and then we can just declare the rotation speed up here. Serialized field, private float, rotation speed. And you can just set it to maybe 3 for now. Alrighty, and that works for all character movement types because it doesn't have anything to do with the movement. And so you'll see that when we go towards a position, it will now look at that direction. And you see that when we freeze the rotation on the rigid body, we can still manually rotate it through code here, which is nice. Alrighty, and now last on the list, we just want to make sure that we are hitting the correct object, raycasting against the correct object. And to do so, in this case, you can do it either layers or tags. So you can tag an object. So here you can assign a tag to an object, or what I like to do, I like layers better. So in this case, I like to add a layer, and I'm just gonna call this ground. And then you can click on your ground and assign the layer that you just made. I feel like that just makes it easier instead of having a bunch of tags on different objects. You can just have all the grounds be on the ground layer, but it's up to you. And then in our script, what you can do is get a reference to our layer, which is an int, private int ground layer. And you can do here ground layer equals layer mask dot name to layer, and you can pass in the name, which is ground. So this converts a name to a layer, and it returns an integer, which is kind of like the ID of this layer. And so now that we have this layer ID, in our raycast, we can compare our layers that are being hit. So here we can do and hit.collider.gameObject.layer.compare to. So we are comparing this layer to the ground layer. So this compare to returns 0 if they are equal. So if that equals 0, and you can look at the documentation for this function if you'd like. So if that equals 0, that means that we are hitting the correct object and that we can start our coroutine. Alrighty, so if we click play now, you'll see that we move here. However, if we click on this box here, you'll see that we can't move towards that area. The gizmo's not popping up. However, we can move if we click on the ground, which is pretty nice. And once again, it's just rotating because I forgot to freeze the rotation on the Y of the rigid body. So that's the end of the tutorial, and this is pretty nice. However, you'll see that if we click past this sphere here, it won't move towards that location. And what you can do is use a navigation mesh, which is a Unity built-in feature, and it will use a pathfinding algorithm to find the shortest path towards that location while avoiding obstacles. However, that is another completely different topic for another video. So
that's the end of this video. Thank you so much for watching. If you enjoyed, make sure to like, subscribe, leave a comment, and hit that bell notification icon. And thank you once again to the sponsor of this video, Southern New Hampshire University. And as well, I'd like to thank all of my patrons for their support. Their support really makes these kind of videos possible, and I really appreciate it. If you're interested, the link is in the description. I offer source code, early access, an exclusive Discord channel, and more. And with that, I'd like to thank all of my new patrons. In the supporter tier, we have thank you so much. In the enthusiastic tier, we have Wolf SV, Thibault, Charles, Marco, Chris, Wagner, Medi, Mark, Sam, Louise, Xiaoying, X Stanzi, Paula, Z, Dor, and Mackenzie. Thank you so much for your support. And in the dedicated tier, we have Cameron. Thank you so much for all of your support. It is super appreciated. Once again, if you're interested, the link is in the description. And if you haven't joined our Discord yet, you can do so. The link is in the description. You can chat, post memes, or ask for help. So thank you once again for watching, and I'll see you next time.